Hello, this is our CM3 presentation. The group is Dejohn, Charlotte Harrington, John Ledet, Sirish Patibanda, and Dejohn Rodrigues. For this tool, we wanted to make something that would streamline the process of scanning through code for like keywords and other like static suspicious patterns. So it's all stuff that you can search for manually, but it takes a lot of time to, search through code manually for like every single kind of keyword that you would be looking for. Structurally, we organized this as like a central controller file, and then each kind of like group of keywords or patterns split into different Python files. This allowed us to have a really modular kind of approach to development.
For the first piece of software we'd like to go over is the keyword searcher. So basically we use a regular expression along with system calls here to look through the binary and find certain keywords. So they're all denoted here. Also, we find a pattern matching with emails, URLs, and base64 encoded strings. So the logic for this is opening the binary, reading all of its data, and trying to pattern match using regular expressions up here. So a quick demo of this. So since our project uses Python virtual environment, so this will be the first thing you do also when trying to use this tool. So I can use the controller here, and here we can see the controller usage. Give it a minute here. And you can see that we have to specify a certain flag. So for the keyword flag, I believe it is -k. And now we can use this password example binary. As you can see, there are many keywords found, and just to test implementation here, we can see that first it found a lowercase password, then an uppercase password. So we can look in Binary Ninja and see that is indeed the case. First there is a lowercase password and then double uppercase.
Okay, junk.py is a script that is designed to firstly disassemble the binary and then identify junk code. So the parts of the code that serve no meaningful purpose and are used to obfuscate and take away from their actual behavior. So firstly, it uses leaf to parse the binaries and capstone to disassemble those sections into assembly instructions. And then we utilize OpenAI to take those instructions that are grouped as functions and classify them as useful or junk based on certain patterns or redundancies. And it focuses mainly on user-defined logic instead of boilerplate functions. And it's able to provide us with a meaningful insight into which functions are useful and which are junk.
So the next flag we had in our controller is flag tracer -t. Essentially, it uses a common tool, GDB, to look at all the register files from the beginning of the executable to the end. So basically, I just wrote a GDB script that essentially does that and run it, and it'll exit once the executable returns. So with we're gonna test the file 4, for example, the argument 4. You can pretty much use a limited amount of flags or arguments, but we're gonna test 4. And so if you scroll up, it says registers at the start of main, and then you scroll down, and then it says registers at the end of execution. And so pretty much it just kind of shows you how values change throughout the executable process.
So this script checks for signs of system calls. Again, it just has like a keyword list that it goes through and pattern matches those against the well, what I'm doing is object I'm putting the binary file into an assembly file, but it pattern matches in the assembly file for like a variety of like system call kind of artifacts. So we can look at how it runs in example 1, but it'll just flag locations where like it's possible that a system call could be run. It gives you line numbers and the rest of the line so that you can kind of go to that line and look at it in context.
Hi, my name is Sirish, and we're going to show you finding strings.cpp. It basically just parses through the binary to find data locations of possible strings, and it will output it in our terminal. Can you show it? Yeah, and yeah, that's it.